It's often useful to be able to calculate areas and distances. In this task, you'll learn how to calculate the square mileage of each Baltimore City neighborhood and then calculate the population density. Here I have QGIS Desktop open with the QGIS map document from Lab 4 Task 3 loaded. To begin, I'll open the attribute table for the neighborhood diabetes layer. I'm going to add a column and then populate that new column with the area and square miles. So to begin this task, I'll click on the pencil, which toggles on editing and puts my table into edit mode. Note that it also puts the spatial layer into edit mode, and you may see these vertices of the neighborhood show up as red X's. Several buttons along the top of the table also become active because I'm in edit mode. I'll click the new column button to open up the Add Column window, and I'm going to name this new column SQMI for square miles. And for data column type, I'm going to make it a decimal number, and I'll set the width at 5. This is the total number of digits the column will hold. Then I'll enter a precision of 1, which is the number of decimal places the column will hold. With that set, I'll click OK, and I'll scroll to the right to see my new column. To populate these values, I'll click on the Open Field Calculator button, which opens the Field Calculator window. This allows me to populate the new columns with values. And this is very similar to the Select by Expression window. I'll form my expression in the leftmost window. I have a variety of operators in the middle window, and on the right a context window. I'm going to check Update Existing Field and set that field to my new square mileage column. Note that you can create a new column in the field calculator itself. Since we've already done that, we're going to update that existing field. I'll set up an expression in this leftmost window. From the list of functions, I'm going to expand geometry and double-click on the $area function. This function will calculate the area in coordinate units of my data, and my data are in State Plane, Maryland, with coordinate units of feet. So this will calculate the square feet of my neighborhoods. Since I want that in square miles, I need to convert square feet to square miles. So I'm going to click the multiplication operator and then enter the conversion factor from square feet to square miles. With the expression complete, I'll click OK. The new field's now populated with square mileages. Now I'll add a second column for population density. So I'll click the Add Column button. I'll name this Pop Density. There's a limit of 10 characters on column names, so you often have to come up with abbreviations. I'm going to make this a decimal number with a width of 6 and a precision of 1. And I'll click OK to add it. And it's added to the right side of my table. I'll reopen the field calculator. Again, check Update Existing Field. Scroll down and choose Population Density. Here I'll divide the population by the square mileage to generate people per square mile. I'll expand fields and values, and I'll double-click on the population column, which is F2010_POPU. Then I'll click the division operator and scroll down and find my square mileage column, and double-click on that to add that to my expression. With this complete, I'll click OK. And now I have population density for all my Baltimore neighborhoods. To save my work, I'll click the Toggle Editing Mode button and save my edits. And I'll close the attribute table. To map these data, I'll right-click on my neighborhood diabetes layer and choose Duplicate, which makes another copy of my layer. I'll double-click this new copy to open up Layer Properties, go to the General tab, and I'll rename this Population Density. I'll switch to the Style tab, and instead of choosing the Diabetes column, I'm going to choose my new Population Density column, and I'm going to change the color ramp to blues, and click Classify to reclassify this data on the new column. Then I'll click OK. I'll turn off the Neighborhood Diabetes layer and turn on Population Density to see the result. Finally, I'd like to look at diabetic density. So I'm going to add another column to the Neighborhood Diabetes layer and populate that new column with the density of diabetics per square mile. So I'll open up the attribute table for neighborhood diabetes, toggle on editing, and click the Add New Column button. I'll name this diabetic density, make it decimal number, again with a width of 6 and a precision of 1, and click OK. And again, my column is added to the right-hand side. I'll reopen the field calculator, set it to update existing field, and set that field to be my new diabetic density column. I'll expand fields and values, and I will scroll down and double-click on my diabetic column, Baltimore City _D, hit the division operator, and double-click on square miles. With my expression complete, I'll click OK, and my diabetic's density column is now populated. I'll toggle out of editing, save my edits, and close my attribute table. I'll again duplicate the neighborhood diabetes layer. I'll go into this copy, switch to the General tab of Layer Properties, and rename this Diabetic Density. I'll click the Style tab and switch the column to Diabetic Density, and I'm going to change the color ramp to orange and red, and click Classify. I'll click OK to accept these changes, and I'll turn on my new styled layer. Now I'll turn on the dialysis centers, and I have a visual analysis of where the diabetics in Baltimore are clustered and where the dialysis centers are located. In this lab, you've learned the basics of performing spatial analysis within QGIS Desktop. QGIS has very robust spatial analysis capabilities, and almost anything you can envision is possible if you have the data to support it. So I encourage you to continue to explore the vector and raster menus. There are also hundreds of additional spatial analysis tools in the Processing Toolbox. An additional resource is the GeoAcademy Spatial Analysis course, and this can be found at the following URLs.